All right, so I want to look at problem 5, which gives us group data for supermarket shoppers. And let's start with copying the table, just like this. We're going to go to Excel, paste that in. I'm going to change it to match the destination formatting. Make my columns look okay. And I'll make this bigger so you can see it. You might notice that it didn't turn these into dates because before, when we had 1 through 10, that looked like January 10th, but 18 to 28 doesn't look like a date, so Excel didn't do anything with that. All right, so the first thing that it asks us is, using the age midpoints X and the percentage of super shoppers, do we have a valid probability distribution? Well, there are two things we want to look for. Are each of these distinct events? Yes, you can't be 28 years old and 29 years old, so they're all separate. And then the next one would be, what do all the probabilities to add up to? So if I add each of these up, I get 100%. So that is my whole sample space. So yes, it would be a valid probability distribution. Looking at the histogram, when I look through, I'm going to say the biggest one is 41% at 34. So that's not the biggest one, that's not the biggest one, that's the biggest one. So this has to be it. That's the quickest way to do that. And then what is the expected age, mu, of a super shopper? So when I'm looking for that, I'm going to go in, pull my formula sheet up. And you may remember this, but if not, it's fine. The mean of a probability distribution is the sum of the value times the probability of that value. So when we go to Excel, I want the sum of x times p of x. So the mean would just be equal to the sum product of this times this. And that's going to multiply them and then add up those products. It didn't work. Let's see. Oh, because I picked one too many. Now I get 42.25, which is believable because my ages range from 23 to 67, and most of the people are around 29 to 39, and the others would kind of weigh it heavily that way. So if I go back, 42.25 is my answer. All right, so then the standard deviation, I have this big formula. I want to take x minus the mean, I want to square it, and then I'm going to use sum product to multiply x minus the mean squared times p of x. So let's do that. It might be easier at this point to take these and to turn them sideways. So I'm going to copy that, right click, transpose. So I have my x value and then I have my p of x. And if I want to say x minus the mean and square it, I'm going to come right here and I'm going to say x, make sure you capture the x one, minus the mean, because I want this to go down, but I don't want that one to go down. I'm going to freeze that, so I'll lock that in with either Alt-T on your Mac or F4 on your PC. Then I'm going to square it, so I'll put parentheses around it and square it. Bring that down. And again, my formula was x minus the mean squared, which I just got, times p of x, sum that up. So I'm going to say equal to sum product, x minus the mean squared, times p of x, add those up, and then I want to take the square root of the whole thing. So I'm just going to go right before and type SQRT and put the rest of it in parentheses. If you want to do that in 2 steps, that's fine. I get 12.67 when I round it to the nearest hundredth, and that was my answer. That's all you need to do.